everybody. In this video, I'm going to start by asking you to remember that time, I think it was Unit 1, and we've seen it a number of times since then, where I want to create the alternating vector that goes 1, negative 1, 1, negative 1, 1, let's say. And there were a number of different ways we first learned how to make this. There were ways where we would just change all of the even elements of the vector, so we'd change the second and the fourth. There was also that way where we said, okay, well, let's take negative 1 and let's raise it to the power. Let's go from 0, and I want it to have 1, 2, 3, 4, 5 elements. And what did I do wrong here? I forgot the dot. So number of ways, but one thing I want to draw your attention to is this choice of function here, this negative 1 and then kind of raising it to different powers. That's not the most natural choice of a function, right? Like if we put in a value of 1/2, for instance, so square root of negative 1, well, that's I, but we're not in a complex analysis class, so maybe this would have been like a strange function to initially think of, and maybe you were even wondering back then, well, what about the trig functions like sine and cosine? So we know that these oscillate between negative 1 and 1. Why can't we kind of make our vector using those? And the issue with that is that we've seen in a number of videos now that there's issues with numerical precision, right? And in particular, if we're thinking about, let's say, cosine, I know that this takes values 1 and negative 1 at multiples of pi, but we've seen pi gets rounded in MATLAB, so at some point we're going to have that it's not kind of equal to 1 exactly, it's not equal to negative 1 exactly. So let's see some examples of kind of why, when we were introducing the alternating vector back in Unit 1, why we didn't use sine and cosine, for instance. So first thing I'm going to do is I'm going to create a new function. And let's see, I'm going to call it alt cosine. I'm going to have an input n that tells me how long to make the vector. And I'm going to have an output v that is the vector. Now, first thing that I'm going to do is, let's say w, let's just make a length n vector, goes from 1 to n. And then I'm going to be using cosine for this function. So remember, cosine, this takes values 1 and negative 1 at multiples of pi. So I'm going to take w and I'm going to say it's going to be equal to pi times w. So take 1, 2, 3 all the way up to n and just multiply it by pi. So that's good, and now I can say, well, v is just cosine of w. Now, one thing to keep in mind here is I want my function to start with positive 1, but this function here starts at 1 times pi, that's pi, so cosine of pi is negative 1. So I need it to start at an even integer multiple of pi if I want it to start with 1. So instead of going from 1 to n, I'm going to go from 0 to n minus 1. And now this will start at 1 and then go to negative 1, 1, negative 1. So I'm going to save this, save it as alt cosine. And now I can say, okay, well, let's try alt cosine of 20. So what do we expect? Well, cosine. We expect a length 20 vector that goes 1, negative 1, 1, negative 1. Oops, and I've written out the full name for cosine here. Let's save it again and try again. So we can see here, 1, negative 1, 1, negative 1, length 20 vector. And we can try things like, okay, well, so this vector is stored as answer. I can say, is answer of the fourth position, let's say, is this equal to negative 1? And we say MATLAB returns true. Okay, that's good. What if I did, so this is going to be a mistake, but if I do answer of 20, well, what's wrong with that is that answer, as soon as we did answer of 4 equals negative 1, then answer got updated to the logical value 1. So if we really want to be talking about the length 20 vector, I should say something like v is equal to alt cosine of 20. And then we can say, is v of 20 equal to negative 1? And yep, that's also equal to 1. So you might be wondering, well, this looks like it's working just fine. Why couldn't we have done this in the beginning? And the reason is, again, because of numerical precision. So we're working with multiples of pi here, and in MATLAB, pi is rounded. So maybe for 20, up to 20, it was fine, but again, because of this precision, I know there's going to be a number for which this breaks down and where we get that alt cosine of some position is not equal to 1 or negative 1 exactly. So I'm going to show you how we can write a script now to find a value that's going to kind of fail. So I'm going to close the editor for our function. Let's make a new script. And I'm just going to check the even multiples of pi. So let's start at a equal to 0. And what I'm going to do is I'm going to say, so while cosine of a times pi. Now remember, I want to check where this fails to be equal to 1. So while it is equal to 1, what I'm going to do is I'm going to increment a. Now it'd be very natural to increment a by 2 because remember I said we're checking even multiples of pi. But because I kind of know where a shows up, where an a that breaks the function shows up, I'm going to tell us that we really should add 10,000 each time. So if I increment by 2, it's just going to go way too slow. It'll take too long. So I'm going to increment by 10,000. Then I'm going to end. And then I'm going to display a. I'm going to save this. And let's call this alt test. Oops. And now let's run the script and see what it returns. So we can see here that it's saying 27,300,000 is where, if I call my cosine function alt cosine of this value, it's going to fail. So let's try it out. If I do cosine of 27,300,000 times pi, and I ask, is this equal to 1? Oops, and I keep doing this. I keep wanting to type out cosine. We see here, oh, that returns false. Now remember, our while loop was incrementing by 10,000 each time, so if I pick a number that's at least 10,000 smaller, so let's say I pick cosine of 27,200,000 times pi, and I say, is this equal to 1? MATLAB says it's true. So this was an example of how we could check using a script, kind of where's a value of a where cosine of an even multiple of pi is no longer equal to 1. So I hope this video kind of helped answer the question of, well, why couldn't we have made that alternating vector with a trig function? And as always, let us know if you have any questions. Otherwise, I will see you in the next video.